Alright, so this is something worth noting. Regarding the Archimedean property, or Archimedes' axiom 5 from On the Sphere and Cylinder, there's some problems here. So, first off, let's just note what it is. The sort of modern formulation, which isn't really how Archimedes framed it, is given two reals x and y, where x is greater than 0, there is some positive integer such that n times x, so some positive integer n, such that n times x is greater than y. Just for the sake of doing it right, I'll put it in there. There we go. Alright, now here's an alleged proof of this. Okay, so let A, so that's a set, be all nx. If axiom 5 is false, so the Archimedean property, then y would be an upper bound on A. Now let lowercase a be the suprema of A. That basically just means, since we know that there is a category of upper bounds, A is going to be the smallest member of that category. Okay, so basically A is just the maximum that any value of A can be. Alright, now since x is greater than 0 and A minus x would be less than A, and A minus x is not an upper bound of A, we get A minus x is less than m times x for some positive integer m. How about we change this to something that is not distinct in sound from the letter n? Let's change that to k, because as I'm saying it, it's really hard to tell what I'm saying, that I'm not saying this. This is some fucking bullshit. Alright, so now let's change this to A minus x is less than k times x for some positive integer k. But A is now less than k plus 1 times x. And this is within the set A. Now this is a contradiction since A is an upper bound of A. Again, these are stupid names. Yeah, little a is an upper bound on big A, the set big A. But we now have little a being less than something. Okay, so this is a contradiction, and allegedly that proves the Archimedean property. This is one of my main criticisms of proofs by contradiction, because you might notice here all of this, so why this is all bullshit, both the axiom and the proof assume that arithmetic affects infinities. But infinities are infinities specifically because arithmetic does not affect them. You cannot count up to an infinity, right? Anything you can count up to will be finite because you got there. You counted to it. You could just stop right there. Finite value. No arithmetic operations work over infinities. Infinity divided by infinity is undefinable. Infinity plus infinity is undefinable. Infinity minus infinity is undefinable. Infinity minus 4 is still infinity, right? Arithmetic does not have any effect on infinities. That's the entire goddamn point of them. Okay? So, what's happening out here when we get really big is we're in that realm. We're in that realm of infinities where arithmetic just doesn't work, right? And thus, we end up with the consequence that both Archimedes' axiom 5, or the Archimedean property, and the proof of it are both unsound. Yes, your proof is valid, logically valid, given the axiom. It is logically valid given the axiom, but the axiom is unsound, and the proof itself is also unsound. And this is an example where a proof by contradiction is valid, but it doesn't actually tell us anything that's useful, right? And now a consequence of everybody falling for this is you think that in a continuous field, because this applies to fields, right? So in a continuous field, one value, let's just pick a value, right? Let's pick 0. There is nothing that is literally right next to it. That's a consequence of believing the Archimedean property, that algebraic structures like fields obey the Archimedean property, that there is nothing literally right next to 0. How could it be continuous if there's nothing right next to it? How do we go from 0 to anything if we don't pass through other stuff? That doesn't make any sense. You can't. You can't. You're now falling into a Zeno's paradox sort of situation, right? Where you're never able to, Achilles is never able to outrun the tortoise, or the arrow is never able to reach its target. Like, whichever variant of Zeno's paradoxes you want to look at, that's what you end up with. But because you have established this axiom and then proven it within a logical framework, and that proof is valid given the axiom and a few others, you think that it's also sound. It's not. It's not. This is the sort of problem that I've been talking about, that I don't trust proofs by contradiction, because they require your axioms to be absolutely impeccable. And you can't know that. You can't know whether your axioms are absolutely impeccable. Certainly not a priori. So you end up with this crazy problem. And it's really interesting to me, because within analysis, when you take a limit, what you're doing is you're taking an ideal value, which is immediately right next to the value that you can't evaluate. Right? We actually use this concept specifically, and yet you have a proof within conventional mathematics that says it's not even possible to do that. And the core of this notion comes from a time before infinities were understood very well, and where it was just assumed that you could use arithmetic everywhere. In a world where you can use arithmetic everywhere, sure, this makes sense, but the whole definition of an infinity is that you can't reach it via arithmetic, you can't affect it via arithmetic. The things that you're trying to do with it arithmetically, they don't work. They're not going to behave the way that you expect. So trying to apply arithmetic to an infinity, and then being surprised that it doesn't act, or saying that when it doesn't act as you expected, that proves that it's whatever your claims about it go one way or the other, that's nonsense. That's nonsense. Arithmetic not operating the way you expect over infinities doesn't tell you anything other than arithmetic doesn't operate over infinities, which we already know. At this point in time, we know this. So the proof is invalid, the proof is unsound, and the axiom is unsound, as are algebraic structures which are built assuming that the Archimedean property applies. At macroscopic scales, where you can operate, it works. Sure, it appears to be true, but it doesn't scale all the way up or all the way down. It doesn't. It just doesn't.